Set notation is the notation that we use for all of higher level mathematics, mostly in college. You will see some of it in high school, but usually we use it mostly in college level math. There's a bunch of symbolism that is used in set notation, and that's usually what's the most confusing. So those curly brackets that you see on your keyboard, those are called flower brackets. And we will use those when we're talking to indicate any kind of set of answers. We use parentheses usually when we're talking about interval notation. So if our answer isn't just particular numbers, which we would use those flower brackets, we would use the parentheses to mean that there's a interval of answers. So like from the number 2 to the number 5, any number between 2 and 5 would be our answer. So we'd use parentheses for that. So we will kind of go through how set notation works really quickly, just so you kind of have an idea of what you're going to see. But sets are usually given capital letter names. So in this example here, I have the set of vowels in the English alphabet, A, E, I, O, U. So notice the flower brackets, and then each element has a comma after it to denote that they are very separate elements. So capital letters for these sets, set names, we called that A. You could have called it capital letter V for vowels. It doesn't matter how you name it. And then each of the elements are contained in the flowers. Here are some very commonly used symbols in set notation that you might want to get acquainted with. We will be using the first one, the null set, very often, which looks like a 0 with a forward slash through it. That just means it's an empty set. Our set has no answers, so therefore we have no solution. If you use complements, you may see a complement with a capital letter A and then a little apostrophe next to it. Some people designate it with a line over it. You will often see that in statistics as well, complement. Intersection is the upside down U. That means anything that we share or we overlap. So anytime you talk about you want to find the intersection of two sets, what you're actually asking for is the elements that are contained in both sets. The union symbol, which is the U facing the correct direction, that is when we want you to combine both of the sets. So take those two sets, union them, put them all together into one big set. That funky looking capital R, that is the shorthand for the set of real numbers. The set of integers is a capital letter Z. The capital letter Q, weird looking thing, that is the set of all rational numbers, which is anything that can be written as a fraction. That funky looking N is the natural numbers, or what we call the counting numbers. So we start with 1, 1, 2, 3, 4, 5. It's all the whole numbers from 1 to infinity. And then the funky looking C there, capital letter C, that is the set of all the complex numbers. So A plus BI. So anytime you have a complex number, it falls into that set. So those are symbols that you might see often when you are working in set notation. So there's variations in set notation of the way you can write things. So I just have this example. How many ways can we write the set of even numbers that are less than 13? Well, we could just write it as a set. I'm going to call it E. The even numbers that are less than 13 are 2, 4, 6, 8, 10, and 12. There's something else called set builder notation. And let me read to you so part of mathematics is learning how to read the shorthand. So this is where we're going to start. So we're going to start with our set E, and our set is, again, set because we have the flower brackets, of x's such that. That's what that up and down pipe means. That's called a pipe. That is also on your keyboard, by the way. That pipe means such that. So x is such that x is contained within the natural numbers. So they have to be whole numbers, counting numbers, right? X is even and x is less than 13. So that's one way to write it in set builder. You could get even more, like you can also write it as the evens is the x is such that x is an even number, natural number, and it is less than 13. Those two things say exactly the same thing. So you may see it both ways. But set builder is a little bit more complicated. But it's literally, if you take those symbols, you can translate it directly into English. So set notation is usually what we will use. Our textbook does have some set builder notation, especially if you start looking at the answers in the back of the book. If you're doing problems that are in the book, you will see that sometimes they will write their answers using set builder notation. So when we're using set notation to discuss a specific interval of numbers, that's where we're going to start seeing the parentheses. So there's two different that we could see. We could see the square brackets. Those are used on what we call closed intervals, which means the endpoints of our interval are included in the answer. But if we have the round parentheses, that means we have an open interval, and that means our endpoints are not included in our answer. And you may see them either way. And you may have a combination. Maybe one end is closed and one end is open of that interval. So make sure that you're, and you also may have intervals that go all the way to infinity. Anytime you use infinity, it's important to know that infinity is always gets a round parenthesis, because infinity is not an actual number, it's a concept or an idea. So infinities always get a round parenthesis, or they are not included because we don't actually know what infinity is. So here are some graphs. So I have, I like this representation that I made because it's got the inequality first, and then it gives you exactly the same meaning in interval notation with the correct bracket or parenthesis or whatever the case may be, and then the graph that goes with it. So you might just want to take a little time and press pause here and look over all the graphs with all the notation with the inequality, just so you can kind of get an idea how they all kind of go together. I really like interval notation because if you look at the graph and you look at the interval notation, it's really, really close to the same thing. So take a moment and peruse some of these. All right, so let's do some examples. So say you were given the linear inequality of x is greater than or equal to -1. I would like you to write this in set builder notation, write it in interval notation, and then graph it on a number line. So what we are given is inequality notation. All right, so how do I write that in set builder notation? So call your set whatever you want. I'm just going to call it A. So A is the set, and what set are we looking at? We're looking at x's such that x must be greater than or equal to -1. So that is your set builder notation. Notice I literally just took the really fancy words and wrote the symbols that match them. Then it says to write your answer in interval notation. So interval notation, my interval starts at -1, and I want all the x's that are greater than or equal to -1. So -1 is included. So -1 would get a square bracket, and I want everything bigger. So I'm going to go to positive infinity. Whenever you are doing interval notation, please note you're going from smallest value in the interval to the largest value in the interval. So from left to right on your number line. So that would be the correct way to write your interval notation. And I do like interval notation simply because it matches the graph so perfectly. So if -1 is right here, so this would be 0, and that'd be +1. I want all my x's greater than or equal to -1. So equal to means I put a square bracket right there because the endpoint is included. And then I'm going to go all the way up to positive infinity. And notice positive infinity is just to keep going forever and ever. So I've just put an arrow on that right-hand side to denote that I'm going to positive infinity. So there would be your set builder notation, your interval notation, and your graphical representation of the same inequality that we had at the beginning. All right, here's another example. Same thing, here's an inequality. I would like you to write the 3 out. Okay, so let's start with set builder notation. And if you want to press pause and go ahead and try this before me, please feel free to do so. All right, so let's start with set builder. So set builder, this is our inequality, so I'm just going to write my set A, whatever you want to call it, B, is the set of answers such that x's such that they fall between -3 and 1. So there's your set builder notation. Next up is interval notation. On the interval from -3 to 1, notice that -3 is not included because the inequality does not have an equal sign, but +1 is included. So -3 would be on the left. It would have a round parenthesis because it is not included. And on the right, we would have +1, and that would get a square bracket because it is included in your answer. So that is how you would write that inequality in interval notation. And then if we wanted our graphical representation, I would need to start so that I would have number -3 on my number line, and I'd need to have +1. So I'd go through, make sure that that's there. And then -3 is not included, so that's my round. +1 is included, that's where it ends, so that would be square. And any number in between. So I'm going to shade in between those two brackets. So notice the similarities between interval notation and the graphical representation. I really like those. So that's just a little crash course on set notation. Hopefully that helps you when you run into a problem that has the answer must be written in some kind of set notation. So thanks, and come back next when we talk a little bit more about some relations and functions.